Hello and welcome everyone. Today we're going to create a little Pomodoro timer using ReasonML and React. To follow along, you will need to have the BookScript platform installed globally on your machine. First we'll need to generate a new project. So we can use the init command. This app is going to be called Pomodoro. And then we'll pass in the option of theme React hooks so that we can use that template. Then you'll cd into that, open it up. And then you'll also need to install everything. You can use npm or yarn. I'll be using yarn. Now if you open up package.json, there's two scripts that's going to be pretty important for us. Start is going to build all of our reason code and compile it into JavaScript. And then server is going to start the dev server so then we can actually see our code taking place in the browser. So let's open up two terminals and run both of those scripts. So yarn server as well as yarn start. This way you can open up a browser like Chromium, go localhost 8000, and this is the start or the demo project that Reason comes with. Now what's being served is everything in the source directory, and the React hooks template has a couple of components, and in here you can see things that are being used such as React hooks for state as well as the React hook for use effect. We'll go into this with a little bit more detail as we build out our application. For now, we're just going to delete everything in the source directory except for the index file. We're also going to delete everything inside of the index file. And that's because we're going to create a new file called app. And let's quickly just make a hello world React component. And you do this with a special function called make, as long as you add the React component decorator to it. Now, Reason code is a little bit more strict than React code. So if we want to render a string between these divs, we'll have to cast it into a React compatible string using the react.string function. But now we can make use of this component. Our entry file is going to have rendered to element with ID, and the ID is roots, but that's going to be the second parameter. Our first argument is actually going to be the app component that we just created. And then there's one last step that we need to do, and that's in index.html. There isn't a div here with the ID of root, so we'll have to add that in. But once you do that, you can go back to your browser, and upon a refresh, we'll get our hello string. I thought I said world. That's fine. So this is a pretty good starting point. It's a good time to initialize Git. And I'm going to do one thing for convenience. In git ignore, I'm going to add .bs.js so that we kind of get rid of all the noise in the source directory and we don't have to see the compiled JavaScript. With that out of the way, we can stage everything and create an initial commit. Alright, now we can get started. So first, let's define the type of our state. And for that, we'll need the type keyword. And just like JavaScript, we'll open up brackets like an object. And let's start simple with just a simple timer. So the state's going to have seconds and is ticking. And I know we're going to want to use reducer because this state's going to get a little more complicated down the road. So let's also type out our actions. So we'll have a start action, stop action, reset, and tick for now. Let me make sure that's singular action. And what this is called a variant in Reason terms. It's a lot like a TypeScript enumeration or a discriminating union, if you will. So an action can only be one of these and not all of them. And then using the let keyword, we'll define an initial state where seconds, we're going to define as 30 seconds for now. And is ticking is going to be false. And then finally, we could also define a reducer function, which takes both the state and an action. And here we're going to use a switch case. And the case is going to be on the action. And in functional programming, a switch is actually more powerful than a normal switch case. This is what's called pattern matching. I actually need these outer parens, so let's get rid of that. All right, and the reason why pattern matching is so powerful is that we have to match every single one of these actions. So if we do a hover, it's saying that we're not taking into account the other states of stop, reset, and tick. And we'll do that. So start and stop is gonna basically toggle the is ticking. Reset is gonna set the time. And then finally, tick is going to tick down the seconds. So this will be state.seconds.-1. And with all of that, inside of our component, if we wrap it in brackets, we can now use reducer, where you pass in the reducer that we defined as well as the initial state. And that will allow us to grab state and dispatch. So we can wrap this inside of here. We're gonna cast our state.seconds to a string so that we'll be displaying the time. Let's also add two buttons, one for stop, and this one will take an onClick method that will dispatch stop. And I misspelled dispatch. There we go. On second thought, let's just add a button for each action. And that way we'll just be able to debug our timer if anything goes wrong. We're also going to want to use the useEffect hook. And specifically, we're going to want to use the useEffect 0. The number after useEffect refers to the dependency array. In Reason, this is effectively the same as a JavaScript useEffect, except with the empty dependency array. And that just means that this will only be called when this component renders, instead of whenever any state changes. So inside of our useEffect, we're going to have a function to dispatch tick every second. And then we'll also have to return clear interval function so that we don't get an infinite loop. And Reason is effectively unsubscribing from this promise. Now to return this needs to have sum here, just so that Reason knows what type it is. And I believe that's everything we need to do to check our timer. So let's check if we do a refresh. Up here in tiny little font, you'll see that the number is slowly ticking down. And then let's check our buttons. So stop should, I guess they're not doing anything. Reset does though. Stop doesn't work. Let's check why is that. Oh, that's because tick is always ticking down, so we need to have a ternary expression here. So our condition is going to be if isTicking is true and seconds is above 0, then we'll tick down. Otherwise, we'll just return state. So let's check that again. And if we start, timer should go. And then if we stop, the timer should stop, which it does. So our timer is working. So now let's change this to be, instead of just a normal timer, into a Pomodoro timer. So back in our app component, things are starting to get a little crowded. So what I'm going to do now is make a couple of new files. So I have two new Reason files, one for utils and one for a timer component. And I also added a index.css file. So first, let's add the CSS to our HTML. Link with an href of index.css. The rel is style sheet. And type is text/CSS. And then in our, oh actually I meant to make one more file. So let's add a source state.reason. So back in our app component, I'm going to take all the stateful stuff, including the initial state and reducer, and move that into state.reason. And then in our app component, we'll need to open state. This might be a good time to explain how Reason does module resolution. So the make function is basically the equivalent of a JavaScript default export. And then open is giving us the ability to use all the functions inside of that other file. Alright, now let's go into utils and add some utility functions. The first one is just going to be s, which takes a string and returns a React compatible string. That's just a convenience thing. Next, we're going to need to add a couple functions to make our time look prettier and more like a timer. So the first function is going to be pad number, which takes a number that's actually a string, and it's going to be an if condition where we're going to add a 0 to that number, so it'll pad it out. Of course, that only goes for numbers less than 10, so otherwise we'll just return the number. And then we'll also need a format time function, and this one's not a one-liner, so we'll need to open up brackets. So let's calculate the minutes and seconds, which is both division and mod of 60, that's how many seconds are in a minute. Convert this to a string and then also pad it if necessary. And for this, I'm going to use the pipe forward method instead of wrapping it around a lot of parens, just so it's easier to read. So what's happening is that minutes is going to be called by string event to convert it to a string, and then that's going to be called by pad number. And then similar for second string, we'll do the same thing. And what we want to return is the minute string concatenated by a colon, followed by the second string. And I think that's everything that we need to start on our timer component. So let's open up the utilities and make a React component. This time we actually want to give it some props, so we use this squiggly thing to access the props given to it. And we're gonna grab seconds, and I'm gonna wrap it in a div and a span because we'll style it a little later. But for now, we'll just pass in seconds and then type it both to format time as well as S. I don't want it to be formatted on one line, but whatever. And then our app component, we could replace this with the timer component where we pass in state.seconds. And with that, our timer now looks like a real timer. Now let's go to our state and fill this out with the actual Pomodoro switching from work to playtime. So we're going to need to add work time, which is an int, as well as playtime, which is also an int. And we'll do current phase here, which I'm going to define a new type called phase up here, which could either be work or play. Now since we updated that, initial state is now mad at us because we need to fill out everything. So I'm going to add work time of 25, playtime of 5, and current phase of work. And that should be good. We're also going to want to update action. And we have basically everything that we need. We just need toggle phase, and then finally set time. And the cool thing about reason variants is that it can actually take in parameters. So here I can do phase and int, and that'll allow us to only have one action for setting the phase and the time for that phase, instead of having two separate actions for each setter. Now appropriately, our compiler is now mad because our reducer is not taking into account all the possible states or all the possible actions. So we could do that now. So I'm actually gonna move reset down here because we're gonna need to update this based on the current phase. And to do that, I'm gonna have an inner switch pattern match. This time we're gonna be matching the current phase of the state. And for the work state, we're gonna set it to the work time. And we're gonna multiply by 60 here rather than having each time in our state have the exact seconds. And play will do the same thing. Playtime times 60. And then now we can do set phase, which takes in the phase and the number. So here, I'm going to do the same thing using the switch. I spelled this wrong, didn't I? It's set time. There we go. And then we'll be setting the work time and playtime accordingly based on the switch of which phase it's trying to set. And then finally, the last thing that we need to do is toggle phase, which of course we're going to be checking the current phase. There we go. And I'm doing it a reset of just getting everything. So when we toggle a phase, it'll automatically go into a is ticking mode and then immediately go into the timer. So that's everything for our reducer. Now let's make a component that we could take advantage of set time and toggle phase. And I think I'll just name it edit time because I'm not really creative with names, but whatever. So here we'll open up utils and let's add a div first. I think the props that we want is going to be phase and then some input props of value as well as on change. So for the phase, we're going to display which phase that this edit corresponds to. And then we'll have the input with type number. And the value is going to be the string of int of the value that we give it. I need to get rid of these quotes here because we need to interop with JavaScript, so this syntax is going to be a little weird. But we want to get the event.target.value in JavaScript terms and then use that in Reason. And then with that value, we'll call the onChange method that is provided in props. So to use this in app, we'll add it on the bottom of our application component. We'll need to provide the phase, and this one's going to be for work. The value is going to be the work time from our state. And then for onChange, we're going to take a event type and use it to dispatch set time, where the phase is work and then the value is going to be the E. We're going to duplicate this edit time, where all of these values, instead of work, it's going to be play. And I think Pomodoro timers usually call this a break and not playtime. So with that, our Pomodoro timer is essentially complete. And we can start the timer, stop the timer, reset, and the only thing now is we need to toggle the timer. And we can just add a button to debug that for now, where we could dispatch the toggle phase. So switching the timer works, we can reset, and then if we edit the break time, it'll also go up. So we can reset that back to 9 and stop the timer. Alright, the last thing that we'll need to do is style our application, because it's kind of disgusting at the moment. So what I'm going to do is I'm going to get some icons for Font Awesome, and I'll be using the CDN just so we get the CSS for all of them, and add that to the HTML like that, and that should allow us to use all of the font icons. And with that, I'm going to create a new component for all of our timer actions. And timer actions is going to be a component where we just have all of our buttons for the dispatch actions. It's going to use the font awesome of FA stop, and that's where we're going to dispatch reset. For this, we'll want to get dispatch, and since reset is just a state type and not an actual property, we can just use it from open state. I also want the prop of is ticking so that we can conditionally have a second button. And these two buttons is going to oscillate between play and pause, so both of them can dispatch those actions accordingly. This is actually going to start. And one for stop, our application. We can remove all of these buttons here and instead have timer actions. And then we'll also need to add the appropriate state to that. So I'm going to move the browser here so that we could style as we go. So in index, I'm going to want a container, and the buttons I want to have display flex and space them evenly. So if we go into timer, this will be class name of buttons. And then we'll also need to add the container around our entire application. And that is an app on this outer div. The container needs a width, so I'm just going to do width of 60%, I guess. For the edit time buttons, I added these three class names. The label is just display block, and the input itself, I'm just making it full width so that it looks a little better. So in the edit time components, the class name is added here on the outer div, as well as the label. Instead of a switch timer, I think I actually want a header. So I'm going to make a header component. For now, it's just going to be an H1 that says Pomodoro. But I'm going to remove this and add our header component here. And inside of header, I actually want to make some calculations and change the label based on seconds. So we're going to need, and I think I also want to get the current phase. So if seconds is more than 0, I'm going to have just a generic title of time of work or break time. Let's make sure that we have access to the state types. And while we're at it, let's open up utils so we could change this React string to an S. And then if the timer is not running, we can have just a ready for a break question mark and ready to start working. And then inside the string, we can make use of that label. And then finally, I still want to dispatch, so I'm going to add an onClick here. But I only want it to run or be available if seconds is 0, so when the timer is not running. Let's make sure we grab dispatch. And then in the ternary, if it's false, we're going to give it a function that does nothing. So in app, let's make sure we add the specific props. So state, dispatch, and current phase. And while we're at it, I'm just going to destructure everything so that we don't have to explicitly pass everything in to props. We can just have it all implicit. Alright, I have to go to 0. Let's go back to state and test that out. Let's just change initial state to have seconds of 0. And then we're immediately ready for a break. And if we click this, the timer starts going. And we can press play. And let's just add some simple styles. So I do want it to have a cursor because we're gonna click it for an action. And then text transform of capitalize. Other than that, I think it's fine. And then the last thing I'm gonna do is add the timer label to be the size of 4 rem and completely centered using flex. And I actually kind of want to add a progress SVG. So for that, we're going to need position relative on the timer container so that the timer can be position absolute. So we'll center it inside of the container. And the timer itself, we'll add an SVG here. And I'm going to take the stylings from this article on CSS tricks on how to make a progressive timer circle. So inside the SVG, we'll have a circle as well as a path component. The article goes into detail about the math behind all of this, but the CSS classes are pretty simple. We're just matching the height and width to the relative container, and then both the circle and the path are just changing the stroke width, or the fill and stroke colors. So I'm going to edit that we have timer gray and timer green with these attributes, both of which has stroke width and stroke color, but the green one's gonna transform a little bit just so that we can have the little animation. And then for that animation to work, we need to add a max time prop, which means in app we need to add the max time, which is gonna be a switch for the current phase where we add work and play and make sure that we multiply it by 60s. And then in timer, we're gonna also have to add a style attribute. And the way inline styles work in Reason is that we have to use React DOM to make a style. The one that we're going to be using is stroke dash array. And right now I have it set to 50 and then 283, just so that we can see a little preview of it. But this 50 is going to be dynamic, so I'm going to add a function up here called get dash array, where we're going to return the style that we create with React DOM. So first we're going to get the remainder, and for divisions of floats, we need to use the operator of /dot, and we'll also need to convert both seconds and max time to floats because they start out as integers. Then we're going to get the correct remainder number as a time string. So after we do that, we'll convert it to an int, then to a string. This way we'll get rid of the numbers after the decimal point. And then finally, we'll create the stroke dash array string by concatenating the final number of 283 at the end. And then we'll pass it into the make style. And after we save, we should give it a test. So 25 minutes is a long time. So I am going to change the current phase to play, reset, and play. And now it's slowly ticking down. So our application is complete, and I hope you guys enjoyed this video and found it valuable. And if you did, please consider subscribing and checking out the other stuff that I've made.